Okay, everyone, we're going to move on now to a new topic in our unit, and it is called similar figures. Now, we are moving towards calculations and finding missing sides and so on. But before we do so, we need to look at just correct terminology and how to identify things. So if we just read along here, it says, two figures are said to be similar figures if they have the same shape but are different sizes. A diagram drawn to scale to another diagram makes two similar figures. Also, an enlargement or a reduction of a photograph when we reproduce a scale. Now, we'll get more into this later on, but the point is we can have similar figures. They don't have to be the exact same shape, but they still might be similar figures. Well, and why is that? Well, what we're looking at here is we have within these figures corresponding angles, and we have corresponding sides. And this is what we're going to start looking at here. Corresponding angles are two angles that occupy the same relative position on similar figures. Corresponding sides are two sides that occupy the same relative position in similar figures. Now, we're going to get into that, so don't quite worry if that's not making quite too much sense just yet. But remember here, if we keep moving on, when we use a term relative position, you must remember that the one figure might be turned compared to the other. So what they're meaning by this here is, remember, you could have a figure like this. Let's say it's a triangle, okay? Remember, triangles could be turned, okay? And if you look, for example, if I pointed out this angle right here, a 90-degree angle, the point I'm trying to make to you is you see this is the corresponding angle right here. Even though the object has moved, that's okay. They're still similar figures because these two figures might be totally similar, but the point is when you rotate them or enlarge them, they are still similar figures. Now, so here's what's going to happen. Let's move down here and it'll make it a lot more clear. So what you have to learn about is how to label these properly. And what we're trying to label are corresponding angles and corresponding sides. And when we move on here, now before I do this example with you, when I jump ahead, I'm going to show you some of the practice here. And you see, just for you can tell, you have the shape here on the left, you have the shape here on the right. You can tell that it's going to be basically an enlargement or a reduction. They're similar figures, just not the same sizes. When you get down here to number 2, you're going to start finding similar figures, but the point to keep in mind is they could be twisted and turned and rotated. So they don't have to be perfectly the same. They can be oriented a little bit different, enlarged, shrunk, rotated around, moved around. But you still have to be able to find the similar angles and sides. So if I go back a step here, let's look at how you name these. So if you look at example 1, you have two quadrilaterals. Quadrilateral means a shape that has 4 sides, which is what we have right here. Now it says here that the quadrilateral ABCD, which would be on the left, and WXYZ are similar. That one would be on the right. State the corresponding angles and sides. Well, this one's pretty easy because if you look at it, there's no doubt they are different sizes. One's been enlarged over the other, but everything, the relative position is about the same. So if you look here at angle A, the corresponding angle over here would be angle W. So you simply would say angle A is equal to angle W. The same is going to carry on for the rest. So angle B will be equal to angle X, angle C will be equal to angle Y, and of course then angle D would be equal to angle Z. Now those are your corresponding angles. But you also can do that now with the sides. Remember when you label it, when you say a side, when you list a side, you have to name both letters. So for example, this side right here, we would name AB. That's how you write it. And of course, AB will be equal to the side of WX. Okay? Yes, you could write it like they have it down here. So if I showed, you're probably looking, well, he's not doing that the same. You also could write it like this. You could say AB, okay, over WX. That's totally fine as well, okay? Either one of those is going to work. If I keep going here now, although I do think I find my way a little bit easier, but that's no big deal. If you look here, you could say BC is equal to XY. And then you could say that CD is going to be equal to, let's see here, YZ. And finally, we should now be at this connection up here, D to A or A to D. Don't worry about lettering too much, is the same as ZW. The point is, everyone, here is you're trying to identify the similar angles and sides. And this is simply how you go ahead naming them, okay? On the left here, we said the angles were equal to the angles, and on the right, we found which side was angled to which side between the two similar figures. As it says down here, the two quadrilaterals are similar because ABCD is similar to WXYZ. We can use a symbol like this, which means is similar to. So if you look at this, everyone, so what have we proved? Every angle is equal. Every side is equal. Therefore, we have similar figures. We have found the relative positions. So that's just it. So I know the angles, might look a little bit different, or the sides look a little bit different. The point is we have similarity, okay? The angle for A is the same as the angle for W. We've also realized that if you look at the side A to B, I know it's gotten bigger in W to X, but the point is they're in the same relative position. Therefore, we can say that we're trying to find those matches, just like where B to C is in the same relative position as X to Y. Yes, the side length has changed, but they're in the same relative position. And that's all this focuses on here, is trying to find out how to name and match the angles and sides. Okay, let's have some practice with that.